Yes, so last time I showed you some of my examples. Okay, you can go to the resource page. This is my home. This is my account. All right, so that's why you can see the material in my sections. All right, so they are grouped into different sections. So actually, basically, in the first sections, I try to directly open some files here and then show how we can use it, particularly the use of the classroom. Okay. So this set is particularly used for GeoGebra Classroom. That means the student can interact directly with you, right? And so I may not show it directly now, but I think I come back to some ideas of creating simple files. Of course, for the more difficult ones, I can't explain it in short time, okay? Because that may involve a lot of steps, right? And probably you need more skills and techniques later on. But for simple one, I think you can try to experience a little bit, right? How to create some simple file, particularly those about graphing, because I think in most of our curriculum, okay, and particularly no matter IB or DSE, okay, so graphing may constitute quite an important part of the curriculum, right? So I spend more time, although personally, I like those problems in geometry more. Okay, but I think that I better do more about the graphing and functions ideas examples here. Okay, and let's have a look. Now, if you can follow me, all right, then you can come here to the fun page, all right, and see the apps downloads page here. Okay, and I will use GeoGebra Classic 6. Okay. And at the beginning, I say I will use Classic 5, but later on, I find that Classic 6 is also very suitable for general use. Right? But I'm not using the latest one, however, right? And for some reason, I think the latest one may not actually be totally friendly. Right? But this is my personal view anyway. All right, so you can follow me if you want to do the things together with me. Then either you just start here, all right, online, or you can download it. In case you already download it, then you can also use your own version on desktop. That is also very good. Right? It's more or less the same. Right? And now maybe I just started here in my website online. Okay, so that is yes. That now I open the window of GeoGebra, and then I can start creating things in the screen. Right? Are you doing the same? Is it okay?
Yeah.
Yeah. Now, don't worry if you can't follow everything, all right, then I hope that you can come back to the recording later, all right, instead of worrying about how to go through step one by one, right? Now the general starting point is a graphing paper and then an algebra window on the left, okay? If you check here, this menu button, then you can see a lot of choices, okay? And if you look at views, right, views here, that means you can see more clearly what are the available components, right, on the screen. Now you can see that the algebra views, that means the left one, and the graphics, okay, in the middle, right here or on the right, are now opened, okay? But in fact, you can have more, right? For example, you can have the second graphic window, okay? In some cases, I use two graphic windows, okay? So you can now, if I close the menu, then you can see there are two graphic windows, okay? And they can be used at the same time. Sometimes it's quite interesting to compare different graphs or maybe to see the relations about objects. But I may not do too much today about this, okay? Just to let you know, basically you can add more components on the screen, all right? And later on you'll be familiar with this. Now, but I think most of the case we may just use one graphic window and one algebra window, okay? Can you see these options?
Yes.
Okay, thank you. All right. And perspectives is similar. There are some preset, right, options for you, but I think this one is more, I think, useful, right, to select the individual components, right? Okay, now for other maybe choices of setting, you can click here to see what things you can maybe adjust, all right? Usually for labeling, I may not use any labels of objects, right? Or maybe only the new points, okay? And then you can set the decimal places and so on, font sizes, right? And you can save the setting. Particularly if you have already the teacher's account, then they will remember, right, your setting. So remember all these on the left, right, will allow you to do editing or formatting, right? And or maybe the setting of the overall layout, right? So a lot of things can be done here, including saving the files, right, at the top. Okay, how about some graph, right? Some simple graph. Now you can do it on the left, right? Because this is the area that you can input functions, equations, and so on. Okay, and how about, let's say we can input a function f of x equal x squared. Okay, can you do this?
Yes.
Yeah, okay. So now you have a function, right? And then you have the graph here. Okay, and if you look at it, you can zoom in and zoom out. I'm using the mouse to zoom in and zoom out. Okay, so you can scroll and then scroll and then control the viewing window. Now, here is the style bar on the right. Again, I go to the right. Now, be careful. This one is the style bar, right? It's a quick access to some very quick formatting of the objects. But for details, you have to open this menu a little bit higher, right? And so to see more options of editing. Okay, because sometimes you may want to edit the objects here with more details. Okay, but for some quick formatting, then you can just choose this style bar, right? For example, if you choose the function, then you see the style bar will give you an option. So let's say color. Okay, you can change the color, thickness, right, or even the line format. Okay, so we have a lot of options. Or you can show the name. Here is the name. It's just a little f here, right? But also can name and value, or name and value, right? So you can see this is also shown on the graph. Okay, so you can play around with these options. Okay, usually I may not show them. I just make it hidden. Okay. Can you follow so far?
Yes.
Okay. Now, if you click on the function again, there's another option here. You can see that you can fix it, right, or unlock it. Okay. Now, what does it mean when you unlock it? Let's look at it. If I unlock it, then I can move these functions around. Can you see this? Okay, yeah. So just move around with your mouse. It's very useful way to control or manipulate the graph. Okay, and then look at it here on the left. Can you see that the function is also changed or adjusted just because you move it? All right. So that is also a very good way to explain with the student, or even explore with the student, how the functions and the graph changes, right? And then how they correspond to each other, right? Particularly when you, let's say, moving it up and down or in a simple way, then can they observe it in a simple way how the function is changed, all right? So that is quite interesting, because I'm not changing the equation, but I'm changing the graph directly, and then influence the equation, right? And that is the way that quite special about GeoGebra if you compare with other graphing tools. Right? Any questions about this part? Now, by default, it is locked. Okay, so only when you unlock it, then you can move it so freely around. Right? But when you lock it again, of course, you can't change it now. Okay. Another interesting way to change it, I think, is that let me unlock it again. Let me see whether it works. Right? I'm now holding the shift key. Let me see. I may not remember the key. Okay, it's the option key in my keyboard. I'm using the Apple keyboard, okay? And I'm holding the option key and then drag up and down the curve. Do you know what happened? Can you do this?
Yeah, try.
Yeah. So you press the option key and then click on the curve and then try to drag it. Okay? Then you change the curvature. Okay. And once again, in the algebra window, you can also see the corresponding change in the equation. Can you see this one? Okay, so that is a way, again, to discuss with the student in what way the graph is being modified, both graphically and also algebraically. Right? Now, still, you can still move it around after changing the curvature. And now you can see the equation is reflected here. Maybe I make the fonts bigger, right? Can you see my the fonts in my screen easily? I wonder, it may be too small. Is it okay? I change it to 24. Is it better now?
Yes.
Okay. So any question about so far about this manipulation?
Excuse me, how do I remove a second graphic paper?
And you can still, have you already opened the second graphic paper?
Yes.
Yeah. Now, under the View tab, then you can expand this part. and then you can see the choice of graphics tool. All right, if you already opened it, then you simply click again to close it.
Thank you.
Okay, welcome. So yes, it takes time to get familiar with the menu, right? Because at the beginning, also find there's a lot of choices there, right? So it's not easy to remember where to find the options or choices. Right? Okay, so now this is one simple demonstration. That means once you enter a function, right, and there's a lot of things that you can manipulate the objects graphically. Right? So although a lot of people know, of course, how to change the equation. Obviously, you may know how. I guess you may know how to change the equation algebraically on here, right? Or maybe change this to some other value, let's say 1/3. Right? I'm just entering the expressions here, okay? And then obviously you can see the change of the graph, right? But I think that one thing special about GeoGebra is that you can also do it with the mouse, okay? Just like moving the objects around, right? And then correspondingly see how the graph is being adjusted, right, or modified. Right? That is an interesting idea from my point of view. Can you follow? Okay, right. And by the way, when you input anything here, you can also open the keyboard. You can have a keyboard. Now I just moved to the bottom left, right, to open the keyboard. Right. Then you can use the keyboard, particularly if you want to find some special symbol, right? Then you may have to look around here, right, to find that. Right? That can also be very convenient. If you don't use it, of course, you can close it. Okay. Now, and I think quite a lot of you may know how to use the slider. Sometimes people quite often like to use slider. I can just show you quickly if you're not familiar with this. And you can enter value a equals 1, for example, right? And that means I create a new object called a, okay? And it becomes a slider, right? So when you drag it, the values of a can be changed. You can also adjust the range, okay? It can be something from, let's say, from -2 to +10, for example, and you can also specify the step here. And I enter again, then you have a new slider. And the use of this kind of slider is that it can be a kind of parameter, right? So here, if I change this function to a, right, then the coefficients a here will affect, okay, the graph, or you can see the change more continuously or dynamically by using the slider, right? So this can be a very useful tool later on because you can introduce many different kind of parameter in the equation, in the graphical objects, okay, and also make a lot of different kind of changes, okay, at the same time. Okay. Are you okay with this use of slider? All right. Any questions before I move on? So feel free to turn on your mic to talk, or even you may not turn on your camera, all right? So you can still turn on the mic to talk directly. Right?
Okay. Now we are trying.
That's called as applied research. So when you go to this topic, you have to remember this, that in this topic, you're talking about both.
Okay, any questions from Vivian?
So
sorry, I missed the earlier part where I joined a little late. So if I go to the menu, where do I click for this graph? If I go to the main, GeoGebra site.
Oh, okay, okay.
Yeah. How do I go to the graph?
And let me see. Now, if you go to the GeoGebra front page,
okay,
all right, you can see apps download here.
Okay, apps download. Okay.
Yeah, and I'm using the GeoGebra Classic 6.
Oh.
Yeah, and then you can click Start. Okay, then you can use it directly on the web. Right? Otherwise, you can download it to install in your computer, okay? Which will be the same.
Sure.
Same tool there.
Thank
No problem. Okay, then maybe I just continue. All right. Let me know if you have any question. Right? I'll always come back to maybe
So
to
let's look
repeat a
at,
little bit, all right?
problem two.
So generally, I hope that you see how flexible it
the
is,
progress
right, to
of
manipulate, create equation,
Let's
and talk
start
about
with
the
right
characteristic
side.
properties of the
What
equation.
is right
Now, there are
side?
different ways to interact
Right
between the
side
graphic
is
and the
simply
algebra.
that
That is
I
the
do
something
it all
particularly
along.
useful in
Some
GeoGebra
people
because
do
you can
do
move
that.
between the
After
algebra
that,
window and
depends.
graphical window in a very flexible way. Okay, and so I now go back to the algebra window again. Okay, now I input another. Let me see. Maybe I just use. Okay, I use the point. I can use the point object here. By the way, look carefully that you have a constructions menu here on top. Okay, and basically it is more about geometric objects, but it also involve a lot of other elements, right? Mathematical elements, or even other kind of control that you can select here. And then to make it easier for you to use the mouse to create objects on the screen. Particularly, for example, if I just want a point, then I can select this one, the point tool, okay? And then click anywhere on the screen. Let's say I get one point on the origin and another point on the x-axis, okay? And then go back to the move tools when you finish creating things. Right? Otherwise, you will have a lot of points on the screen once you click on it again, okay? So please go back to the move tool, then you can see the arrow, right? Now you can have a try to move the point. So if you put the point B correctly on the x-axis, then the point B will be dragging around here freely, but the point A is fixed and at the origin. Okay, that's why the color is different. But actually, you can change the color anytime you like, in fact. Okay. So you can see the definition as well. A is the point intersection between x and y axis because I just directly click here. And the point B is a point on the x-axis. You may compare. Let's say if I add another point somewhere in the middle, then it is a totally free point. Can you see that? Okay. So C, the coordinates displayed here, but there's no other restrictions on it, right? There's no particular relation defined for C, right? So you can move it clearly on the web, on the screen. Hey, can you follow this map?
Yes.
Right. Now, so based on this value B, now I'm do something more maybe further, right? With the objects on the screen, I can see the value X value of B. All right, I can name it in this way. Maybe I can call this value simply, let's say, just simply use the letter B, right, to represent the X value of the point B. Okay, so this is a particular syntax in GeoGebra. You can use this way to this X bracket of a point, then you will extract the X value. Okay, so you can see B is now just representing the X value of B. Okay, and you can now further use the letter B for other calculation or other components you create on the graph. For example, I can now create another function g of x equal to x times x minus b. Can you follow? Okay, because I have now the value, the new value b defined in this way, then I can use it in other components or other objects. Okay, so if I press enter, then I have a function x times x plus 4. Right? So here it is the function. So when you move the point B, the function is also updated, right, at the same time. Okay. Can you see?
Yes.
Now, maybe you can continue to explore with this. Right? If you go back to the function f, now I can move the function. Maybe I have to unlock it. Go back to the style. I already unlocked it. So can I move it? What's the problem? Oh, I changed the function. Is it? Oh, yes, because I used the A to control the function. Okay, maybe I just simply delete it. Right, I forgot. Oh, sorry. Here, F is here now, independent of the letter A. Okay, then I can move it again and then try to compare. Okay, now what I'm doing here is try to make the graph directly above this blue graph, right? And then try to compare the equation. Okay, so maybe you can also let the student do it this way. That means maybe you let them know. Okay, and if you have a graph, let's say like this, how can you move it? So maybe I just change the scales a little bit. Okay, so I can now have a graph. Okay, now can I move it just above? That's not so easy. All right, yes, I can do it now. So you can compare these two graphs, right? And then try to find out the relation, okay? That means probably you can see the line of symmetry, okay? And then compare it. So you can do it quite, I mean, in a rather dynamical way, all right? Instead of just input the individual equation and ask them to check the relation. And this will let you maybe manipulate the whole things in another, from another perspective, because you can use the mouse to move around the graph and then to create different kind of examples and then make comparison, right? So any question or any suggestions about this? I just want to first of all illustrate how we can manipulate the objects, okay, in the following way, and then also at the same time see the algebraic relations in some way. Okay, this can also be perhaps be part of the teaching design, although I'm not directly talking about a particular ways of using it in the lessons. Right?
Sorry, how did you get the A intersect, like fixed point?
Oh,
How do we?
When you create a point, can you see this?
Oh, yes, yes.
When you create a point, you can either create it freely anywhere on the screen, just like this, all right? Or you can put it on an object. That means I can click it on the x-axis, then it will stick to the x-axis, right? And if you click on the intersection, then usually they assume that the software will assume that you want a fixed point at the intersection. So that's why you click in the origin, then it will be labeled as intersect of the two objects, x-axis and y-axis. Okay.
Okay, so you click at the intersection of the graph.
Yeah, simply click
right?
at the intersection, and then you will see the difference. All right.
Sure.
It's just a shortcut, right? Because they may guess what kind of point you want, right, when you click it. Now, actually, you can also click here on the graph. Now, can you see what I'm doing?
Yes.
Okay. Now I have a lot of things now on the screen. Maybe I try to clear some of them. Okay. I think I can remove this point. I just delete them, right, just to make it easier for you to read. Or even I can use these buttons on the left. I can hide the functions. I think I can hide the function G. Okay, then you can have only the function F. Okay, now I do it again. When I add a point, this time I add a point on the curve. Right. So you see now it tells you that this is a point on the function F. Can you see this?
Yes.
So C is stick to the graph, right? It is now kept a point on the graph. Okay. Can you do this?
Yes, we can do it.
Try. Yeah.
Now, at the same time, let me also try to just a little bit. At the same time, maybe I can now move back to the, I try to adjust the window first, okay? Okay, now you can see more clearly the point. Now I can indicate a point above point C, okay? And maybe by 2 units, all right? How can I do it? I can do it in several ways. I can write down C plus 0, 2. That means I use it like a vector, okay? 0, 2, you can imagine that it can be, they will interpret it as a vector, actually. All right, so you can press enter. Then you have a point D, which is directly above C, okay, by 2 units. This is one way that you can add a point depending on another point. So, and you can operate or combine the points like what you do with vectors. which can be a very easy way for you to create new points. Okay, and can you follow this?
Yes.
Okay. Now, and what could be the use of this? And maybe we'll go back to the graphic menu here. You can see one option is apart from adding line and line segment, you can add a vector. Okay. Now, but for this vector, I just want the arrow actually. I just want to use it to indicate I have a point above point C. Okay. And I can change the color of it to make it a red point, to make it more clearly indicate, or maybe I can turn the vector into dotted line so that it may not be so obvious. Okay. So now you can see the point D is always 2 units above the point C. Can you see that?
Yes.
All right. And then now you can trace the point. Okay. So I right click the point D and then show trace. Okay. Now you can move it slowly. I mean, move the point C slowly. And then you can ask the student to imagine what the point D will trace if you continue to move the point C, okay? What graphic or what image you will get, all right? So that is the way to talk about how the graph is being translated, right? Or being moved, but I'm not moving the whole graph at the same time. Right? Sometimes I work on specific points, right? To let the student concentrate on just one point, and then imagine if I continue to do it, right? What will be the graph look like? And then let them talk about it or make a sketch. Particularly if you're doing online teaching, then you may invite the student to make a sketch on the screen using the annotation tool, okay? And if you're doing it in the classroom, then depends on what tools you have. Just like what showed you last time in the GeoGebra classroom, right? You can invite them to manipulate at the same time on the screen, and then you can see the students work at the same time, right, together, right? Or you can just simply invite them to come to the board and then to talk about how the graph is changing. Oh, sorry, I just make changes accidentally. Okay, so you can trace the whole graph in this way. You see this? Okay, so that is the effect of moving the graph upward, right? And afterward, of course, you can also add the function. And this is f of x, okay, plus 2. Right, then you can see this is a new function added. Exactly, it is a graph that I just want to trace with the point D. Okay. So in this example, you can see how I use different elements, both the algebraic objects, that means the functions, the points, coordinate, and vectors on the left, and also graphically, objects that I can manipulate and trace directly on the screen. To talk about the relation between the two, both the graph and also the algebraic elements. Right? Okay, maybe that's more or less what I like to do with this first example, and then I may try to just move on to some other examples while we still have some time left. Okay. Any questions about this one?
I just want to go back and ask, how did you add the extra function fx equals to x squared? How do you add another function?
This one, f,
yes,
or the one h?
Yeah, that one, fx plus is equal to x squared.
Oh, you just type inside. Okay, for example, if you have you click inside any open, this blank cell, then you can start typing, or use the keyboard.
Oh,
you see the keyboard?
Mine, I don't know. I'm not sure why mine is not giving the option of adding like the plus sign. Maybe some problem.
How about the keyboard? Can you see the keyboard? Now, if you use the keyboard, right, then you can now you can see how I type this step by step. I go back to different tab, all right, and then I press X. Can you see this? I'm typing it step by step, and then plus. This is the plus, and then 3. But of course, usually the keyboard, your own keyboard should already. Yeah.
I think I got it.
Able to type it. All right, just enter. Sure. But by the way, you can also see how I can use this keyboard. Okay, directly provided by GeoGebra. Okay.
Thank you.
May I ask that? Can we make how is it supported for multi-variables?
What do you want?
Can we draw a circle in this
Or draw a
graph?
circle. Yes, you can. So you want to try circle?
Yes, it does have two variables in the function.
Oh yes, yes. No worry. Now maybe how about I clear some objects here because I don't know whether you can see the screen clearly. Okay, and maybe I just clear some objects first, all right, so that you can see more clearly what I'm doing. Okay, so yes, you're right. I just demonstrate basically functions of a single variable x, all right. But for other functions of two variables, you just type directly what you usually do on paper, just like x squared plus y squared. For the square, you use the cap, okay, in the keyboard to do this. Can you see this?
Yes.
Okay. It can be more complicated. It can be, let's say, something like this. Then it will be ellipse, okay, or a hyperbola, okay, or even something more complicated. Let's say minus xy. Then I don't know what happened. Okay? Or maybe y to the power 3. Okay, why not try something more interesting? For example, something like that. Okay, and then how about let's add a parameter k there, and then turn this into a parameter. I don't know what will happen. Too complicated. All right, so I just go back.
Okay.
How about this one? If I turn it into k, I think it's still also quite interesting. Just this is the curve. I'm just playing around. It's quite interesting. Do you see what I'm doing?
Yes.
Right. So there's a lot of things that you can do. Yes, you're right. Just simply type any equation with two variables, x and y, then you will have an object like this. Later on, if you even try the 3D screen, then you can also type variables with, equation with three variables, x, y, z.
Yes. All right. Fantastic.
Yes. So experiment with this. By the way, if you just want a circle, remember that there's a lot of ways to create circles in this environment. Okay. Maybe I just quickly show you. I can use this tool, use the mouse to create circle with the center and the point. Okay. And we'll just delete some other objects. Okay, so this is the circle C. Can you see this one? Okay. Now, but this is generated by the point I make with the mouse. Okay, and the equation is shown here. Okay. Similarly, you have all the other options. Right, you can experiment with that. Another interesting one is just create circle from 3 points. Okay, so you can have 1 point, 2 point, 3 point. Okay, and then you can quickly still see the equations. This is the equation. Even when you move the point around, then you can still see the equation. Okay. And you may wonder where's the center, because from the equation you can see the center. Actually, otherwise, just go to the midpoint options, and you can indicate the center of the circle. Right, so there's a lot of ways to create and then adjust, right, or modify objects. And also, don't forget, you can always go back and forth between algebra and geometry to talk about the relation. That is exactly why the software is called GeoGebra. Okay, there's a geometry and algebra. Right, at the beginning, I think the basic idea is to try to combine, right, both aspects of the mathematics in this app, right, and this environment. And I think it does right well. You can see that there's a lot of flexibility in moving, creating, and modifying objects between two ways. Okay? So try to make use of this feature, right, in any other of your coming lessons or any ways of teaching. I think that is a very important element to be considered when you design the use of this tool. Okay? All right, maybe, yes, we can try some other examples later, all right, very soon. All right. How about Jeannie? Do you have any suggestions?
No, not at all. Very clear, Arthur. It's yeah, very straightforward. I hope people see the power of combining the algebra and geometry, because in lots of systems they teach it separately. Like in the US, they teach it separately. So it's important that we combine and see the different representations.
Yeah. So that is one critical element, right? So making use of the dynamic and then connected, right, multiple representation, right, in mathematics. So that is quite a general idea that we can keep in mind and bear in mind. And by the way, you can also see that although you can find a lot of well-designed and complicated GeoGebra applets on the web, right? But now what I show you today is just the basic steps, right, or simple steps in creating objects. But you already reflect some very important use or very useful way of doing things in mathematics. And just like the circle idea, just a few steps you can already indicate how the point, the objects is also reflected in the equation, and then talk about a lot of geometric and algebraic relation in this way. All right. Now, of course, if you can find other useful apps, then you can always keep a collections of good tools you can find. At the same time, try a little bit every time to create something on your own, no matter how simple it is, right? But you build up your experience and skills in this way, I believe. Or don't forget, talk to your classmates, right? Anytime, all right? Share your ideas, share your questions, right? Then you will, I believe that you will learn more and then do things more quickly very soon. Right? Okay, now you can keep this file if you like. That means maybe you can save it. You can have the ordinary way to save it, but interestingly, you can only save it under your account on the web, right? You don't save it directly on the desktop, right? I don't, well, someone will comment on this and have this practice, right? Whether it's convenient or not, right? It's up to you. Maybe you can decide. But don't forget that you can save it anyway, right? And then you can come back to your file later. But if you have already logged in, just like what I'm doing here, I've already logged in. That's why I can save my file, all right? I skip this part, right? Maybe you can explore with this later. Now, how about I come back to my examples? If you go back to the GeoGebra page, okay, the main page. Sorry, where's it? Quite strange here. Oh, that is the, oh, this is my browser. I know what's going on. Okay. All right. Now, and then the GeoGebra tabs, let me see. Okay, I go back to my own resources, all right? And I can particularly share with you one set of materials that I used before. It's called STEM workshop, which I have done around 2 or 3 years ago, okay? There may be still some useful element for you to consider. I copied the links here. So this is the link. All right, and I copy in the chat area. Okay, so you can come to my page if you like, right? Just something maybe I can quickly pick from my collection and to indicate and share with you. Some of this file may look quite complicated, but I hope that you can have a try and then try to analyze the material inside. I do it for some demonstration in STEM education, okay? But I think it is also useful in general for math lesson. It will include some kind of transformation tools and also tessellation and something about animation, okay? Because when I do animation, I use a lot of parameters and transformations of function, just like what I demonstrated previously, but I put it into context. Instead of just doing arbitrarily, right, how to transform, change the function, we may talk about animation or even modeling, okay? So some examples are about modeling here, okay? So you can go through these examples later on. Particularly, I would also like to recommend a book, right, before I forget, okay? So this is a book that you can find in our library as an ebook. It's called Mathematical Modeling Application with GeoGebra, right? And inside this, there's a lot of examples from the author, okay, talking about the use of GeoGebra in different occasions, right? And many of them are about what we call modeling, okay? And this can be a very useful ideas in our teaching as well, because now in our classroom, in our curriculum, we may want to introduce different kind of exploratory materials to the student, or sometimes make use of examples of modeling, talk about some mathematical ideas or principles. Okay, so I like this book because there you can see a lot of details, right, and explanation and demonstration. Although the interface here may be a little bit old because they are using a little bit older version, right? But still have a try in case you want to further know more about the details, then you can come back to me, or if you find any other examples interesting here. Okay. So you can see this title, okay, mathematical modeling application with GeoGebra. I will put down the link in my website later, right, and to alert you where to find it. Okay, so that means my examples here are also in the same sense, okay, as a kind of modeling examples, talking about how to make a cone, changing its size, and then see how the shape and volume or surface area change. Okay, so you can play around with this setting, and then later on you can find that I use more than one window, right, a graphing window, right, so that I can also talk about the changes, right, in the volume of the surface area, right? And the other one here is a bit simpler because I don't show the geometric objects, which is more complicated, but just the algebraic element, I think is also very useful for students to understand, okay, this important concept, right, of variables, functions, and modeling concept. And I also include a video to demonstrate the steps, so you can follow my video to see the individual step if you're interested in this example. Okay. So maybe I just pick one animation examples in order to welcome the coming Halloween. All right. Would you like this? Okay. Now don't click the place button, okay, because the sound is very horrible. I'll tell you why I edit later, right? But don't click on this now, right? Just concentrate on the animation. That will be good enough. Now, in case you don't know where I am, I just copy this link and then put it in the chat area. Okay, so you can start to think about what graphical elements are included here. Right? I can hide this part, and oh, sorry, I cannot hide it. There's some problem with the with the setting online, okay? But you can see the functions there, all right? So I'm just using the functions we learned in the curriculum and to create this animation, or you can also invite the student to guess. So what different functions, graphs are involved here, or even invite them to make a draft, right? To try to suggest how you can position the objects, right? And then try to make this kind of animation, okay? Now, of course, it involves a lot of kind of parameter and changes, right? So I can go through some with you. You can go scroll down to see the PDF file. In the PDF file, then you can see the detail. I list all the elements in the graphic. Okay. So maybe now I open another window to share with you. Let's see. I go back to the no. Maybe I should start a new. Okay. I mean, I just start a new graph here. Okay, and then take it out so that I can put it on top and then go back and forth to two windows. You need not open two windows, right? You can maybe just concentrate on your own GeoGebra window, right? But I just let you know that actually what I input is already in my PDF. Is that okay?
Mm.
So you can start with just like what we have done earlier. I start with f of x equals 4 minus x minus a whole square. Okay, so that will be a parabola, and you press enter. Now you can see that they automatically add a parameter a. Okay, although you can also adjust it later on. And actually, you can see a little play button here as well. Okay, so if you click play, then you will see how they just varies the values of a, okay, continuously. This is the basic way to create the animation actually. Okay, can you imagine? Now you can come back to this one later. I set it around here anyway. Okay, so that is the first equation I entered. Can you follow me? Do you see the PDF file? Okay. Now you can follow every step, then go back to the PDF, right? Then I think you will also see the details yourself very easily. Okay. And now, in fact, if you have time to work with the student, I would suggest you to continue to invite the student to guess what the equation could be, all right? To create the animation. For example, how can you create the lower part, right, of the ghost, something like this, all right? to let them suggest some possible equation and then adjust it. That will be more fun, I believe. All right. But for the time being now, I just skip it. Is it okay? So
You
this
make
is my-
you hide in the animation. Did you hide or
I will change the color and the opacity later. Yes, you're right. Of course, this is just the graph, right? But you don't see the ghost directly because later on I will do something to highlight the regions and then change the background color, and then to have the effect that you see at the beginning. Is it what you want to ask?
yes.
Okay,
Yes.
you can see later in the later part. Okay.
Okay.
So I can just go through quickly with the rest. Okay, the GX is now the sign. Actually, it should be 1/3, right? And then in the equations there. Now it depends. You can change it later on because this kind of coefficients, I think you can experiment with it, right, to see what is the better picture that you want. Okay, so I just press another parameter B here, which you don't know what it is now. Okay, and this does not exist yet, the parameter B. Okay, if I press enter, then the software will add it automatically for me. Okay, so you can have a try, and then you can see that when you drag it, then it looks like fine. It looks like what I show you in the animation. Okay, then maybe you can just stick to this. Okay, and then you can press play button, both of them here, and they will move together. Can you imagine what it looks like now? Okay, because they're moving together, then it will come up with the pictures I showed you earlier. And at the same time, on the main screen, you can also see the one major button to control the animation on the lower left. Right? So if you click this, everything stops. Right? And you play again, then both parameters will be turned on. So that is the way you can work the parameter. I hope you can follow a little bit, all right? But if you can't follow everything, don't worry. Maybe we can try it later. Is it okay so far?
Oh, which button that control both parameter?
Here, can you see the lower left? Once you start animation, you have to start it first. When you've started, then you will see a new button added on the lower left, right, to make you control both parameters at the same time. Okay. Yeah, then we can try later, or just do this individually. That will still be fine. Okay. Okay. Now I go to next page of my PDF. Okay. So I will show you how to get this area later. All right. And even the eyes, so you don't see the eyes yet. All right. Sorry, it's already here. Oh, I forgot. Yes, here. Where is it? Yeah, this the circles. Okay. So you can enter the. Now, don't forget that you may have to experiment with it. All right. I just give you. By the way, I use the same parameter A, right, so that the circle will be positioned relatively in a special way, relative to the parameter, right? Sorry, the parabola. Okay, so 0.1, all right. So I think this looks fine. One of the eyes. Can you see this? So here is the equation, which is the one I put down in the PDF file. Okay. I just quickly put down another one. Okay. So when I think of the circle position, I just imagine where is the line of symmetry of the parabola, right? And then quickly think about some possible way of putting the circle relative to the line of symmetry. Okay, that is the way that you can experiment with this.
Where is that blue line from?
Which one?
Never mind.
Yes, which one?
Never mind. You were editing the function, but it shows it appears on the graph.
Yes, I have now two functions, f and g, corresponding to the quadratic, yeah, and then the sine curve, and then two equations corresponding to the circles. Can you see this?
Yes, there was that y equals to x. That was the line. Y equals to
Oh,
x.
oh yeah. Now,
Editing.
because when I start typing, I think you will talk about this. When I start typing, let's say I start type X, okay? Then you see a line. Just because I have not finished the typing the equation,
Yes. Yes.
okay? So when you continue to type, for example, as x minus 1, okay, whole square, but I haven't finished it, all right? So you may wonder why you have a parabola here, but don't worry. Once you finish typing, then it becomes a circle, okay?
Sure, thank
Is it
you.
okay?
Yes.
Okay. Yes, it may look quite confusing sometimes. Okay. Okay. So now this is the you now can see the main features of the ghost pictures appear now. All right. And then you can now scroll down. I'm scrolling my PDF file. Okay. And then how I create the regions. Actually, I use some tricks here because I use the integrals. Okay. Integration. Right. So I'm using an integration command to create this area. Actually, the integral actually means the regions between f and g from the point A and B here. Okay, x of A means, do you remember x of A means the x coordinates of A? Okay, so from this point to this point, you mark this region, and that is the integration, right? So you can have the area as well. By the way, even if your student haven't learned calculus, I think it doesn't matter. Just let them know there's a command or there's something in mathematics that allows you to indicate the region or even find the regions, right? But for the technological tools, you can take this as a kind of something different, right? That means you have this button or you have this command to do things. That will still fine from my point of view, right? Some teachers will worry that, oh, they haven't learned calculus at all, right? But I don't see it this way. Right? Why not just simply tell them, or there is a mathematical object called integration, and then you play around with it using the buttons, right? That will also be fine. But in the way here for this demonstration, I simply want the regions, okay, being indicated and filled here. Right. So if you follow my step, then first of all, I have to indicate the intersection. So I just use the intersect command. And then f and g, okay, a minus 9a. That means I have to indicate around here from which point to which point to mark the indication, the intersection, okay? Because there are two intersections, so I mark the one on the left first and then the one on the right. Okay? That's the way I create the intersection. Or you can maybe try clicking on the graph directly to mark the intersection. I think that can also be done, okay? But I want to do it more precisely here. So finally, I just quickly go through the integrals. All right, so this is the integral command. All right. And I want this to start from the x coordinate of A to the x coordinate of B. All right, then you can see the region. All right. All right, now maybe now I should try to finish it quickly because we should now come to the end of the sessions today. Right. Now I already show you the rest actually in I think somewhere down here in my PDF. No, not directly about the background. Anyway, just change the color. I can let you know how to do this. Okay, you can change the color of this region. This is the region C, and then if you click on this, then you can see that you have option of changing it, or maybe you can find out more. You make it a white options, and then stop it, and not enough. I have to make the opacity. I think yes. This is the opacity, transparency, okay? And it becomes a white one. And how about the circle? The circles here, instead, I have to turn it on, perhaps. What's the color? Oh, it should be black, yeah. Okay, sorry, that's the point A. I mixed it again. Okay, I should choose the circle. Circle is here, right? And the circle, I can turn it into something black. Why I can't see the circle?
Oh, Maybe the circle is at the back. You have to put it to the front.
I don't think so because they have. It should be in same. But anyway, I can try to. Okay, your thank you for suggestions. Let me go to the editing field. Now I quickly open the editing field and then choose the objects properties.
Mm.
Oh, it is hidden. I mean, you have to make it wider now. So you can see the equation A, the circle, okay, just like what you say, in case you wonder whether it's now being hidden, then I can move it up one layer. Let's see whether it works. Okay, yes, good. Right, so you can do it later. I just leave it one eye. Okay, that will still be fine. Okay, now you don't need the graph. I mean the sign graph. You can just click to hide it. Okay, then you have just the goals here. And the background, finally take away the grid, take away the axis, then you don't have the background. But you still have to turn the background into black color. I'm now opening the background option to make it black. So that's why you see this one now. Okay. Okay, so enjoy this. All right. I hope you like this animation or discuss it with your students in case you want to talk about transformations of function or even making animation. So when you finish it, maybe you can just close the window before you save it. Okay. So I should close it. I can close the left window. Then you can have only the this graphic window left behind, right? To let the student guess what the equation will be, right? So that is the way I do this for my file. And finally, I also include a sound file, but that is not very good. I just experiment with it, all right? I find that the effect is quite horrible anyway, but you can have a try, right? I can enter a sine curve is another sine curve, but then specify it as a sound wave, right? Instead of a graphic picture. This is a very interesting element to add in the GeoGebra, right? And yes, that is the things I put in the file here. So I close the PDF. That is on my original file. Okay, so I hope that you can see some possibility of using different kind of tasks, including with the animation, modeling, okay, in order to talk about properties of functions, their transformations, right? How they can include parameters to see the changes in the function. In our textbook, they may talk about it in a very abstract and theoretical ways, right? And I hope that you can consider different kind of exercise activity to let the student know how they can be engaged in this kind of activity or in a more meaningful way. All right. So later on, if you can think of other